In this video, we'll be walking through the MATLAB script that we wrote to analyze the curves of solar graphs. So as you can see here on the screen, this solar graph contains the path of the sun through the sky over a period of several months. And we were interested in knowing how we can mathematically analyze the edges of these curves in order to compare and contrast the different outputs we get from various solar graph images. So now as we go to the script itself, it starts by reading in the image that we want to analyze and assigning all of its properties to variables that can be used later. Then it's going to use various filters from the image processing toolbox available with MATLAB, starting with the grayscale filter and moving on to a threshold filter. And so this threshold is currently set to 203, but it can be adjusted depending on the contrast within your image and in order to basically get a better fit in the end. From there, it uses a black and white area filter in order to find the single largest continuous area, typically representing the paths of the sun itself, and then inverting that, allowing us to analyze it to find the edge. This loop down here is going to get the point of either the top edge or the bottom edge throughout the entire solar graph, and the top or bottom parameter can be controlled by this variable here that's currently set to last, but can be changed to first to find the opposite edge. From there, it's going to open up the curve fitting toolbox where you can clean up the outliers of your image, and then once you're done with that, it'll display the various coefficients of the regression fit and give you your output file with the curve fitted onto your image. Now we're going to walk through how to use the script to analyze the curves on this example solar graph. So you're going to want to make sure that this image is in the same directory as your MATLAB script, and you're going to take the name of the image, which in this case is Solar1, and change the variable name, image name within the MATLAB script to match the file. So once you have that ready, we'll run the script, and it's going to first start by applying the various image processing filters onto the solar graph and producing this final inverted output of the black and white area filter. So once this image has been produced, it's then going to open up the curve fitting toolbox that you can see on the right, and also it's going to open up this help dialog box that says push OK when the model has been saved. So we're going to go ahead and minimize the help dialog box for now and focus on the curve here on the right. So here it is displaying all the points from the edge detection algorithm that it uses, and if we're looking back at our solar graph, we're seeing that this graph on the right represents the bottom edge of the sun's path on the left, of course inverted on the graph that we see here. And so we notice that there are a bunch of points here that don't seem to line up with the exact fit of where the sun would be going, and so we're going to have to do some processing on the graph. We're going to start by turning off the legend here on the top left so we can see it better, and we see that the curve here is using a first degree polynomial, which of course is not what we want. So we'll change it to a fourth degree to fit the double curvature of our graph. And then, as we see here, it's not fitting very well. So what we can do is use the exclude outliers tool here in the top left and box select all of the points that are obviously off of the path that we're looking for. And as we do that, we start to see the fit of the curve getting better and better. And here, as we get these last outlier points, we get a pretty well-fitting curve for the path of the sun. So once you have the curve that you want, you're going to go to Fit in the top left and Save to Workspace. Make sure that the object is saved as Fitted Model here in the first box, and go ahead and click OK. And now that our model's been saved, we're going to reopen this help dialog box and push OK. And once you push OK, it's going to output the coefficients of our fitted polynomial, which in this case is a fourth degree polynomial, so we get 5 coefficients. Then it'll also show us in our figure the updated image with the fitted polynomial over the bottom curve of our graph. And so you can do this on any solar graph that you have. You can also change the detection algorithm to get the top edge instead, and go ahead and post-process that and see how that turns out.